All right, concept 1 in unit 1, one-step equations. These are very, very, very basic equations to solve. We're going to do some equations. The first 3 examples have to do with addition and subtraction, and then the last 3 examples have to do with multiplication and division. Each word problem will be different. This one will have to use addition or subtraction. This one will have to use multiplication or division. So first of all, to solve simple equations, we need to use inverse operations to isolate the variable we're trying to solve for. So remember, isolate means get by itself. We want to get the variable alone. And the variable is a letter, typically X, Y, M, N, it doesn't really matter. It's a letter that represents something. Represents something. We don't know what it is. That's what we're trying to get. We're trying to figure it out by using inverse operations to get that by itself. And what we're trying to get rid of are the constants, and the constants are just numbers without a variable attached to them. Okay, because there's numbers that are attached to a variable, so we're going to numbers without a variable. W/O means without, and then coefficient means a number with a variable. Typically you'll see coefficients in multiplication problems. With addition and subtraction, you're not going to see these because we're not going to need to get rid of those, but you are going to see constants. So let's get started with the first 3 examples. So number 1 says s minus 5 equals 3. To solve this, we need to figure out what is the opposite of subtraction. We can look at our little movie clicker thing here where it gives you the opposite operation. So it gives you the operation and then it tells you the inverse of that. So we have subtraction. So to use the inverse of subtraction, we need to use addition. We need to get whatever is happening to s away so we can get s by itself. So to get rid of minus 5, I need to add 5 to both sides. Because the equation symbol means it's like a balance, whatever I do to one side, I have to do to the other to keep the equation balanced to make it true. So the whole reason I added 5 was to get rid of it so I can cross it out, because negative 5 plus 5 equals 0, and anything plus 0 is just that thing. So it just goes away. We can just cross it out. So on the left side, I have s equals 3 plus 5 is 8. And that's it. Pretty simple. Let's do number 2. T plus 5 equals negative 25. All right, I need the inverse operation for addition. So the inverse operation for addition is subtraction. So I'm going to subtract 5 from both sides. So plus 5 minus 5 is 0, so they go away. T equals negative 25 minus 5. Now, the trick with subtracting negative numbers is to remember they're just like adding positive numbers, just with a negative sign. So I can think, well, what is 25 plus 5? Well, that's 30, but the only thing that's different is they have a minus sign in front. So it's negative 30. All right, and finally, our last one-step equation using subtraction or addition is this guy. So this guy says negative 46 plus q equals 5. Now, this is a little tricky. It seems like we want to use subtraction to get rid of this because it's being added, but really we're looking at the sign in front of the number we want to get rid of. Since there's a negative sign, which is the same thing as a minus sign, we're going to use addition to get rid of it. Another way you can think about this is instead of saying negative 46 plus q, I can rewrite it as q minus 46 equals 5. If that makes more sense to you, rewrite it that way. That way you're not confused with how many signs there are. So I'm going to solve this one. So to get rid of the minus 46, I need to add it. These go away. Q equals 5 plus 46. That is 51. And we're done.